This is Food Chemistry Unit 3, Chapter 12, Enzymes, the Protein Catalyst. The human body does not use protein just to build tissue. The second function of proteins is to provide amino acids to build enzymes. Enzymes are proteins that start chemical reactions without being changed by the chemical reactions. Many enzymes are involved in the development of food products. Enzymes, specialized catalysts. A catalyst is a substance that starts a reaction between substances without being affected by the reaction. So they participate in chemical reactions, but they are not the reactants or products and do not change when in use. Meat tenderizer is a good example. It breaks down the protein in meat and makes it softer. Activation energy. Every reaction needs a certain amount of energy to start it. This is known as activation energy. Enzymes lower the activation energy or lower the amount of energy needed to start a reaction. In digestion, for example, you have digestive enzymes that let chemical reactions occur without using much heat energy. Proteins can be broken down in 4 hours. If enzymes were not present, it would take much longer. So this is just a good example of a reaction, right? This is the activation energy of a reaction. Here's without a catalyst. Look how much farther down it is with the catalyst. So they lower that energy needed for the reaction. Working model. Enzymes are very specific. They fit exactly with what's called a substrate that has an active site. And enzymes work like a lock and key. The enzyme, like right here, is the lock, the substrate is the key, and this active site is like the keyhole. So this has to be an exact fit or it's not going to work. Now, there are some exceptions. You could have what's called an induced fit. The enzyme is not quite the right size, but will take on the appropriate shape as the substrate approaches. You can also have a coenzyme. This is a substance that needs to be present for the enzymatic reaction to work. These would be things like vitamins and minerals, like your B vitamins, calcium, magnesium, iron, and zinc as minerals. So it has to be an exact fit, but you could have an induced fit or a coenzyme to help out with that. Factors that affect enzyme activity. Water availability. If there's not enough water, reactions are slowed or stopped. Enzymes won't work in dry products. Concentration of solution. The more substrate, the greater the rate of reaction. So enzymes will have more material to work with. Factors that denature enzymes. Enzymes are proteins. Their shape can be changed. If this happens, the substrate will no longer fit the active site. Heat. Blanching is where you plunge vegetables into hot water to stop the enzyme activity. Then after maybe like 5 minutes, you place them in ice to stop the cooking action. So the heat from the blanching denatures the enzymes. It keeps them from altering flavors when vegetables are frozen or packaged. And it often gives them that nice bright color. Acids and bases. Enzymes have an optimum pH to function properly. So pepsin, for example, is an enzyme in your stomach, and it works best at a pH between 1.5 and 1.7, so pretty acidic. Rennin is used to make cheese, so there should be a pH no more than 5.8, so it's still acidic, but on the higher end of that scale. If you add lemon juice to apples, right, like in this picture, you will stop the enzymatic browning of that fruit, because lemon is an acid, right? Electrolytes. These are positive and negatively charged ions in solution. The most common example is salt. It binds to enzymes in foods that cause spoilage. So you have mercury and lead, which are poisonous, and these are obviously stop enzymes. You have iron, calcium, and potassium. These are coenzymes. enzymes, so they would be needed for certain processes, right? So if that enzyme substrate doesn't have the best fit, these could come along and help it out. Enzymes and the food supply. The food industry has three basic uses for enzymes. These enzymes are are commercially produced and sold to manufacturers. So one function is to convert one food product into another. Enzymes can convert milk to cheese, right? Using rennin. You can extract food components from food systems. Pectinase speeds up the separation of juice from insoluble residues. So this pectinase is the enzyme, and it can help provide a clearer juice and a better yield of that juice from the fruit. You can have development of new foods and ingredients. Lipases. These are enzymes that convert palm oils into coconut butter, into a coconut butter equivalent and produce oleic acid from beef fat. Oleic acid is used to make margarine. All right, changes in food from enzymes. So on the positive side, they make foods easier to eat. This is your meat tenderizer. They preserve food. Milk is converted into cheese. They can improve flavor, quality, and appearance. If you add lactase to milk, the result is a lactose-free product, since the enzyme broke down the sugar, right? On the negative side, you have this rotting action. It breaks down the structure of food. The food becomes soft and mushy. Unpleasant flavor changes can occur. Fat turns rancid over time in storage. Raw vegetables that are frozen too long will no longer be edible. And apple slices, right, turn brown quickly. That's the result of enzyme action. Carbohydrases. These are enzymes that specifically break down carbohydrates. You have your amylases, they break down starch in your mouth, right? That's in your saliva. Cellulase breaks down cellulose. Lactase breaks down the sugar in milk. It's added to dairy to reduce the lactose for lactose intolerance. Lipases, these are enzymes that break down fats. They improve the flavor and texture of cheeses, ice cream, margarine, and butter. Proteases are enzymes that break down proteins. These are meat tenderizers. They break long protein fibers into short fibers. The meat becomes easier to chew. Meat tenderizers have a limited time of use though. There's usually instructions on the package. Marinating meats, this is your meat soaked in a flavorful solution. Many have vinegar, wine, or juice, and those acids, right, from the vinegar, wine, or juice, denature those meat proteins. Enzymatic browning, the enzyme phenolase reacts with oxygen. Fruit is bruised, right, or bumped, whatever, the browning reaction is going to start. Apples, peaches, and pears are very sensitive to browning.